Good day, everyone. The first thing I want to mention is that our course is not a course in programming. Rather, it is a course in working in a team on solving a real-life problem using programming. So the challenge for me when I designed the course was to invent a project that is, first, too big for one person, and hence it requires teamwork. Then it should be doable with the knowledge of a second-year math student. Then an important characteristic is that the project should be boiled down to a list of tasks that can be distributed among team members, and that there should be a sufficient number of tasks for all team members. And then, so one more thing that I had in mind is that while some tasks, of course, require non-trivial programming because it is still a course in algorithms and computing, so there should be some tasks that don't require non-trivial programming so that even students who are not very good in programming can have a chance to shine. So, and I hope that you will like the project that I came up with. So it is about simulating spread of information over an online social network. And the main purpose is to simulate a real work environment. So the idea is that when you graduate from NTU in 2 or 3 years, then chances are that you will work in a team on some, I don't know, usually it is analytics projects or data science projects or something like that. But we want you to be prepared. So, which is why you have to take this course in sort of in project work. Okay? Now, the objectives of this course project are the following. So you need to learn how to load real data into Python. Then you're going to summarize the knowledge on random network models, right? Then, so notice that here, so some models are familiar to you. Erdős-Renyi model and Watts-Schroger's model are familiar to you from our regular classes. Then Barabás-Albert model, I'm going to explain it here, but it is sort of, it has the same flavor. All of them have been implemented in the library NetworkX, but mediation-driven attachment model is something new that you have to implement from scratch, right? So the idea is that you need to learn how to implement these models from scratch. Now, you need to look at characteristics of those models and compare them to characteristics of Facebook to decide which of them is most suitable to resemble Facebook and to model Facebook. And then you're going to simulate spread of information. And then you're going to feed parameters of spread of information into real data. And then you need to present your findings so that there will be a presentation and the final report. So there is a list of tasks in the project. So I highly recommend that you distribute these tasks among the team members according to their strengths and abilities. Well, how you distribute tasks and even whether or not some tasks are really considered as tasks depends on your team. So the first task is, of course, is being the team leader. So telling everyone what to do. So, of course, in some teams that there is an obvious team leader who does that. In some teams, they just work together and they discuss everything together. So the first task may or may not exist in your team, right? So the second task is implementing this mediation-driven attachment model. It is challenging. It requires non-trivial programming, so it should go to a student who is good at programming. Well, the third task is implementing one more model of your choice. Now, this can be either easy or extremely hard. So depending on how the challenge that you choose, you might get a lower or a higher score for the task, right? So if you just decide to use some existing model in NetworkX, then this is easy. It's just one command. So you'll probably read a little bit about the model and I don't know what properties it has and so on. But then it becomes really easy, and this can be merged with, say, another task. But if you decide to do the hard way, like if you decide to read a difficult research paper about some new model, or if you decide to invent your own model, then it becomes much harder, and then this task can go to a student or maybe even to two students. So the fourth task does not require non-trivial programming, so it's just summarizing all the knowledge and putting it together. So if you have a student who is not very good in Python, then you can assign this task to her or to him. Task number 5 is implementing spread of information using the SIR model. Is hard. It is challenging. I don't know what is more challenging, the MDA model or SIR model. Both are challenging, so both should good to students who are both should go to students who are good in Python. Then task number 6 is fitting model parameters into data. In my opinion, it is an easy task, but some students find it challenging. I don't know. So I think it's not very challenging, really. And then tasks number 7 and 8 are about slides and the final report. So note that I will allow you to make your slides in Jupyter Notebook, like this. The slides I'm going through right now. So they're made in Jupyter Notebook. So it's just they're very easy to make in your Jupyter Notebook. You just indicate which cells become your slides and which cells should be skipped. Now, if you want to do that, then it's easy. And it does not really require another person to be assigned to. So then it can be counted together as just one task, as slides and the final report. But if you want to, you will not be penalized for making slides in Jupyter Notebook. But if you want to, I don't know, assign presentation to another student, to someone whose job is just presentation, and if you want your presentation to really be excellent and very beautiful and have animations and so on and so forth, then maybe 7 and 8 should be different tasks. Well, and finally, there are some resources for the project, so they are available on NTU Learn. Now, the most kind of comprehensive one is Newman's paper. A lot of this Newman's paper we have already learned through our labs 1 to 7. So, but then mediation-driven attachment network is not covered in Newman's paper, so you need to read. So the student who is doing that should read another paper about just that model, MDA model. Then there is a paper about particle swarm optimization. It's really optional. So if you want to read about it, you can. Otherwise, you just use particle swarm optimization, right? And then I strongly recommend that you look at last year reports of your seniors. So I uploaded them there for your inspiration. I chose 4 or 5 reports who got highest scores for extra effort, right? So I'm not saying that these are reports that have been presented the best of all, or they're not reports with the best coding of all. Some of them have very good coding. I don't know, but the reason I chose those reports is that these are reports that got highest scores for creativity and extra effort. So which means that you can look at them for source of inspiration.